In this lecture, I will share what is meant by dimensional formula of a quantity. First of all, let me share the definition of dimensional formula. It is an expression that shows how fundamental or basic quantities represent the given quantity. Fundamental means mass, length, and time. Let me take an example in order to understand this definition. Suppose the quantity is speed of a body. I want to find dimensional formula of speed. First of all, I will consider its definition. Speed is defined as distance divided by time. Using this definition, I can find dimensional formula of speed. It is a tradition to represent dimensional formula with this type of brackets. Now, distance can be represented as length raised to power 1, and time can be represented as time t capital raised to power 1. I can rewrite this as L1 t minus 1. Further, I can mention mass raised to power 0, length raised to power 1, time raised to power minus 1. This result is nothing but dimensional formula of speed. So let me repeat the definition. It is an expression that represents how fundamental quantities, fundamental means mass, length, and time, represent the given quantity. Given quantity is speed. So speed can be written as mass raised to power 0, length raised to power 1, time raised to power 1 minus 1. This is how we can find dimensional formula of any quantity. Let me take some more examples. Suppose we are to find dimensional formula of acceleration. By definition, we know acceleration of a body is defined as rate of change of speed, means change in speed divided by time taken to change that speed. This is the definition of acceleration. Using this, I can find dimensional formula of acceleration. In the numerator, we have speed, so we shall write dimensional formula of speed L1 t minus 1, as I proved earlier. In the denominator, we have time t raised to power 1. After simplification, I can write L1 t minus 2 power. I can write it mass raised to power 0, length raised to power 1, time raised to power minus 2. This is nothing but dimensional formula of acceleration. One more example. Suppose we are asked to find dimensional formula of force. Again, we shall consider the definition of force. Force is defined as mass of body multiplied with acceleration of the body. We know this part. So dimensional formula of force can be found as, put dimensional formula of mass m raised to power 1 multiplied with dimensional formula of acceleration, just I have found m raised to power 0 L1 t minus 2. After simplification, I can write m1 L1 t minus 2. So this result is dimension formula of force. Next I will share what is meant by principle of homogeneity of dimensions. This principle says that powers of fundamental quantities, that is mass, length and time, on either side of a relation must be same. In order to have more understanding about this definition, let me take an example. Suppose we have a relation S equal to V naught T plus half A T square. We all know this relation, very popular, where S represents distance traveled by body in time t, V naught represents speed of body at starting time t equal to 0, and here A represents acceleration, that is constant acceleration of the body. So we have to apply this principle of homogeneity of dimension. So what is the meaning of this principle? This principle says if I find dimension formula of this term S and the term on right hand side, there are two terms on right hand side, dimensional formula of all these three terms must be same. Means powers of mass, length and time will be same. Let me prove it. Suppose I want to write dimension formula of S. S is nothing but distance, so I can write m0 l1 t0. So this is the dimension formula of term on left hand side of this relation. Similarly, dimension relation of V naught t, this second term, we can write is equal to V naught is speed, it will have L1 t minus 1. It will be multiplied with dimension formula of time. Time is nothing but t raised to power 1. After simplification, I can get m0 L1 t0. Now let us take the third term. In the third term, it is half a t square. If I want to find dimension formula of this, half is a constant which is dimensionless, and acceleration is L1 minus t minus 2. This is dimension formula acceleration. Capital T raised to power 1 is dimension formula of time. It is to be squared. After simplification, I will get m0 L1 t0. It is clear from these three results that each term on left hand side as well on right hand side has same powers of mass, length and time. Mass has power 0, length has power 1, time has power 0. So this is the meaning of principle of homogeneity of dimension. Again let me revise. Powers of m, l and t on either side of the relation must be same. This is called principle of homogeneity of dimensions. Let me share one more example. Suppose we are given x equal to a plus bt plus ct square, where x represents distance and t represents time. Question is, what is dimensional formula of a? What is dimensional formula of b? What is dimensional formula of constant c? All these three are constants. We have to find dimension formula of these three constants. This is a question. We shall make use of principle of homogeneity of dimensions. This principle says dimension formula of x on left hand side, dimension formula of a first term on right hand side, dimensional formula of Bt and dimensional formula of Ct square, all these terms must have same dimension formula. Now to calculate dimension formula of left hand side, it is distance, so I can write m raised to power 0, l raised to power 1, t raised to power 0. Similarly, dimension formula of A must be same as that of x, m raised to power 0, l raised to power 1, t raised to power, so 1 answer is there. Now we have to find dimensional formula of B. For this purpose, I will write dimensional formula of Bt must be equal to same as that of x, that is m0 l1 t0. So this will give us dimensional formula of B multiplied with dimensional formula of time. Time can be written as t raised to power 1 equal to m raised to power 0 l1 t0. After simplifying this thing, I can get dimensional formula of constant B as equal to m0 l1 t minus 1. This is the second answer. In order to find C dimensional formula, again I will follow the same steps. Ct square must have dimensional formula same as that of quantity on left hand side, x, that is m0 l1 t0. From here I can write dimension formula of C multiplied with dimension formula of t with square is equal to m0 l1 t0. After simplifying, I can find dimensional formula of C as equal to m raised to power 0, l raised to power 1, and t will be equal to minus 2. So this is the dimension formula of C. This is how we can find dimension formula of all the three constants by using the principle of homogeneity of dimension. That's all.